come up. Okay, this is the Montagues and the Capulets and their propensity to fall in love. And so here we are talking about their average score on whatever test it was that they took. Okay. So, you know, you need to be aware that on some of these problems, even that problem that was about the errors, is it on the, oh, it's on this page. Number 16, about the errors. I don't see how you can do these problems without thinking about what the hypothesis statements are. Okay, so be aware that you might have to envision what these hypothesis statements are, even if it's not specifically asking you to state those. So, for example, on this Montague and Capulet problem, I determined that the null hypothesis is probably that the average for the Montagues is the same as the average for the Capulets, and then it's asking for a difference, so the alternative would be 2-tailed. Okay, so then from that, the key to solve this problem is your t-score. And so, with a t-score of 1.75, what do you know about standard deviations away from the mean and being unusual? Is 1.75 going to be a very unusual sample? No, it is not at all. For t's, for sure. So 1.75 is well within 2 standard deviations. So I am not concerned that my sample is a whacked out, way outside sample that calls into question the null hypothesis. So in summary, since this t-test is just 1.75, I would not expect to get a really small p-value. That would cause me to reject a null, so therefore I'm going to fail to reject. Therefore, the Capulets, actually I marked over the question, the Capulets are not significantly different from the Montagues. Yes?
Are the parameters of two standard deviations on a z-curve the same for a t-curve?
If you're asking, okay, this is actually a good thought. Here's the normal curve. Okay, and so if I go, say this is a z-score of 2, okay, then I'm going to have 2.5% out here. This is an approximation. Okay, but on a t-curve is more varied. So let's think about this, okay, which I heard that coming out here. So a t-curve is going to actually have more in the tails. So even if you were at 2, this area in the tail of a t-curve, I mean, I'm exaggerating here, is going to be larger than what it was in the normal curve of 2.5%. So certainly at 1.75, there's going to be way more than that 2.5% for sure, okay? So that's why you know you're really, really safe. All right, so there you go. That was how I came up with that decision. C was pretty straightforward just from your number 15 was pretty straightforward just from your basic understanding. I had somebody ask me earlier about this because they had forgotten about it and hadn't seen it in a while, and the question was, are there going to be any error questions on the test? And my answer is, maybe. I don't know. So don't forget this stuff. So here's the type 1 and type 2 error, which you know the foundational concepts of. All right, so you can read that, and I don't think I really had any questions on that. So let's go on to number 17 is the